So now that we know some basic VHDL, it's important to learn some other VHDL constructs as they can help you create modules. So let's go back to our bacon ice cream chocolate spoon example, and I have right on the screen right now the truth table that we had come up with, where we have three outputs that give us a yes, that's a nice combination on the spoon. And then remember, we had come up with a VHDL module for this, where we had the entity spoon and we define the inputs and the outputs, and then we have the architecture, where we've defined each row, not B, I, and not C, not B, I, and C, and B, not I, and not C, which you can see right here. So there are multiple ways of defining an architecture, and I'd like to go over those right now. So we'll keep this up for the moment. And if you go on to PolyLearn, you'll see there's something called the VHDL cheat sheet, and this here gives you all the different VHDL constructs that might be useful when you're creating your modules. It's divided in half between concurrent statements and sequential statements. So concurrent statements happen all at once, meaning when you list a bunch of statements like A gets something, dat gets something, these things are executed at the same exact time, meaning both of these run in parallel. Whereas everything in the sequential statements happen one right after the other, just like in a computer. So if you did something like if this then that, that happens before the next statement that says else if this then that. All sequential statements must occur inside a process block, and we'll be discussing that. So any of these constructs on the right hand side are options to be put inside the process block. Now the process itself, you could have multiple processes running in parallel, which is why the process itself is on the concurrent side of this sheet. Whereas inside the processes happen sequentially. Alright, so let's go over how to use these different expressions. So far you have used what is called the concurrent signal assignment, where you just assign your output variable to some combination of the inputs. And this is what we have already done over here with this architecture. Now another concurrent option is called the conditional signal assignment, and here it shows you what the format is, where your target or your output is some expression when something is true, else expression when something else is true, else something else. So in our case, if we were to write our bacon ice cream chocolate module using the conditional signal assignment, this is how it would look like. So instead of this, I'm going to go ahead and just list them. Actually, I'll just go ahead and delete this. So in this case, again, we have our target, which is our output S. It's going to be assigned 1 when what conditions? Well, if we look back at our truth table, it's when B is 0, I is 1, and C is 0. So when B equals 0 and I equals 0. Oh, what did I say? And I equals 1, sorry, and C equals 0. And C equals 0. Else, it's going to get 1 again for our next row, which was B is 0 and the others are 1. I'm going to just copy these. B is 0 and the others are 1. Else, our last one was when B is 1 and the others are 0. Those are all the one conditions, so our last else is else 0, meaning for every other input you're just going to get a 0. So now we have used the conditional signal assignment to describe our truth table. All right, let's look at the selective signal assignment. The selective signal assignment has a chooser expression to select the different target expressions. So we need to create a chooser expression. The easiest way to do this when we have three things that are being our choosers is to create an intermediate signal. So we're going to call this, and when you declare signals, you put them before the begin statement. So declare intermediate signal, or actually I'll call this here our chooser expression. So we're going to declare signal, so we call it signal. I'm going to call it bacon ice cream chocolate. BIC is the name of this signal. And it's going to be of type standard logic vector 2 down to 0. So I'm creating a signal that is of bit width 3, meaning there's 3 bits that are going to make this signal. Alright, so then the first thing I need to do in my architecture is define what this signal is. So I can say BIC is equal to B concatenated with I concatenated with C. So this operator, the ampersand, means to concatenate the signals, meaning join this individual signal with this individual signal with this individual signal to create here a 3-bit bus. So now I've created this new signal that's 3 bits long that's comprised of these individual single-bit signals. So then I could say, now I'm using my selective signal assignment, I can say with BIC select, notice here I am following along this format, with BIC select that spoon is going to get the value of 1 when the value of BIC, once again our first one, is 0, 1, 0. So when 0, 1, 0. Or it's going to get a 1 when 0, 1, 1. And a 1 when 1, 0, 0. And then 0 when others. It's always important to have your when others clause so your code knows what to do if you don't have any of these conditions. So there you go. Now we have done the selective signal assignment for our same circuit. Alright, so the last concurrent signal assignment is the process itself. So like I said, the processes themselves are concurrent, but what goes on within the process is sequential. So the process, I'm going to go ahead and delete these because we're going to do a process statement now. Process again goes inside the architecture. You got to give it a name, process 1, process. And what you put in these parentheses here is what is called a sensitivity list. Sensitivity list goes inside parentheses. I'm just putting that comment there so you can see. So what a sensitivity list is that you need to put whatever variables in there that you want the output to change when they change. So it usually involves the inputs of the function. So if B, I, and C change, we want this process statement to be evaluated so our output can change based on these input changes. Alright, so we're going to begin this process. And here we're going to go ahead and use an if statement. And this is going to look very similar to how the the conditional signal assignment looked like, except now we're within a process. So what's going to happen is if B equals, I keep forgetting the order of these, 0, and I equals 1, and C equals 0, then S is going to get the value of 1. Else if, I'm going to copy these again. The next one was 1, 1. Then S gets 1 again. Else if, actually I'll just copy this whole thing. The next one was, the last one was 1, 0, 0. Then S gets 1, else S gets 0. End if, and end process. So yes, every if has to have an end if, every process has to have an end process, every architecture also has to have an end. So notice all these ends that line up. Okay, so we just did a behavioral model because what happens is each of these statements gets executed sequentially. It doesn't all happen at once. It's always a good idea to use concurrent statements when possible because they are faster, because they happen simultaneously. However, sometimes it's really useful and easy to code up if you use the behavioral models because it allows you to do these if-else conditions. So the last one is, as you can see in the sequential statement, we already looked at the if and else if construct. There's also the option of using the case statement. So this case statement is going to look very similar to the selective signal assignment, where again we're going to need some chooser expression and then producing an output. So again, I'm going to keep my process actually. Now because I'm going to be using a temporary signal within the process, I'm going to declare chooser expression here. So it's again a signal BIC gets standard logic vector 2 down to 0. And now in my process, I'm going to have the case BIC is when it's the first one, keep forgetting, 0, 1, 0. I'm going to scoot this over. When it's 0, 1, 0, I'm going to get S gets 1. When the next one, which was 0, 1, 1, S gets 1. And I'm not going to keep writing this because I think you get the idea, but you finish out the case statement like this, and there you have it. So it's very useful to know these constructs, and you'll be practicing them in your problem set. So yes, it's either on page, this cheat sheet is either on page, oh, I just pulled up the cheat sheet, but it's in the textbook as well. So yeah, thanks.